Hi, welcome to this short presentation on Newton's first law, forces and free body diagrams. You'll be drawing free body diagrams for your rocket to describe the forces that are acting on it, so hopefully this video will help you. Newton's first law is the law of inertia. Inertia just means that an object at rest will stay at rest unless some force acts upon it. So that makes sense if you think of a penny sitting on the ground. It's not going to go anywhere or do anything unless a force acts upon it. The second part of Newton's first law is that an object in motion will stay in motion unless some force acts upon it. So this is the part of Newton's first law that's a little trickier sometimes. And basically it's saying that when something is moving, it'll continue to move in the same direction and at the same speed unless there's a force that changes that slows it down, speeds it up, or makes it change direction. So again, think of that penny. If I come along and I kick the penny, it'll now be moving, but it will stop. As it slides across the floor, there's a force of friction, and that force of friction counteracts its motion in a certain direction and eventually would stop the penny. People used to think that objects sort of just naturally came to a position of rest and that they just sort of ran out of energy and stopped. But now we know that's actually forces. The little picture there is the Voyager spacecraft. That's the first man-made object to leave our solar system. It's been cruising through space for many, many, many years and just continues to go because there aren't any forces that counteract its motion in the direction and at the speed that it's moving out there in space. So some different types of well, let's just define force. It's not exactly the same thing as force, what we think of from Star Wars, where they use the force, but force is just a push or pull on an object. So some examples of different types of forces would be friction. Friction opposes the direction of motion. So again, sliding that penny along the floor, there's friction. So if the penny is moving in one direction, friction is slowing it down by applying a force in the opposite direction. Air resistance. This is another force that'll come into play with your rockets. As objects move through air and they push against the air pushes back against them and slows them down. So if you think of someone jumping out of a plane, as they fall, as they get faster and faster and faster, there will be more and more air resistance slowing them down. Third is an applied force. This is a force, what we usually think of as forces that are physically pushing or pulling on something. So again, if you come along and kick that penny, you have applied a force to it. Fourth, force of gravity. So the gravity is a downward pull, and on Earth our force of gravity accelerates objects at 9.8 meters per second squared. But that'll definitely be a force that comes into play with our rockets. And then lastly, the force of thrust. This is a force that propels objects forward like rockets. And there are a lot of other forces, but we're not going to get into a lot of details right now. But basically a force is just anything that pushes or pulls on an object and could affect its motion. So free body diagrams then are just a way of showing the different forces that are acting on an object. And we show both the magnitude and the direction of the forces with these little models. Magnitude means the strength of the force acting on the object, or the relative strength of the force. And it's shown by the length of the arrow. So in the diagrams you're going to draw, you won't have specific numbers to attach to each force arrow or vector, but you will, the ones that are stronger you will be drawing as longer arrows, and the ones that are weaker you'll be drawing as shorter arrows. It also shows the direction of the force, and of course that's just shown by the direction of the arrow. So if you look at the example over there on the right, we have the force of gravity pulling down on the object, which we just signify with a little box. It doesn't matter if it's a penny or a rocket or whatever. We have what's called the normal force pushing up. We're not going to get into that too much. We have an applied force pushing to the right, and we have the force of friction pushing to the left. And in this case, you can see all those forces are balanced. The force of gravity arrow is the same length as the normal force arrow. The applied force arrow is the same as the force of friction arrow. So this object would either just not be moving at all. It would just be sitting there, or it would be moving along at a certain velocity, a certain speed and direction, and that wouldn't be changing because all of the forces are in balance. Here's some other examples of free body diagrams. You can see this one up here in the upper left-hand corner. We have a force of 5 newtons pushing back on the object. We have a force of 5 newtons pushing to the right, and then we have a force of 5 newtons pushing down on the object. That might be the acceleration of gravity pushing down. We could label these areas. These examples don't have the labels arrowed, but arrows labeled, but we could label them. This one over here in the upper right-hand corner has a force of gravity pulling down on the object, has a force pushing up on the object, maybe a little bit of thrust, then it has a force pushing to the left and a force pushing to the right. If we look at the one in the lower right-hand corner or the one in the lower left-hand corner, we could think about what are the forces that are pushing on these objects, and ultimately how would that affect their motion. If you'd like to have some practice with drawing the free body diagrams before you start to work on your diagrams for the rocket, you can go to this website. If you go to the slideshow in your physical science shared folder under Unit 2, you can click on that link, and there's a nice website there. It has some examples that you can use and do some example problems. So now you take this information and you're going to be applying it to the flight of your rocket, thinking about what forces affect the flight of your rocket. You might ask questions like, what forces must be overcome to lift the rocket off the ground? Or why doesn't the rocket sail off into space once it gets going? Or why does a rocket change velocity during flight? Why does it change speed or direction? If there are changes in motion, then there are forces at work. Because again, Newton's law says that an object at rest will stay at rest unless a force acts upon it, and an object in motion will stay in motion unless a force acts upon it. So you'll be drawing free body diagrams of your rocket for the technical report and asking what forces affect the flight of a rocket. I hope you find this video helpful, and be sure to check out those practice problems as you move forward and start thinking about how to do these diagrams for your rocket.